you frame human intelligence as rational adaptation under tight limits. So explaining biases, heuristics, and few shot learning, so learning from a few examples, which is what LLMs don't do, as optimal use of limited time, limited computational resources, and limited bandwidth for communication. So it seems like that, I didn't even really get to a question there, but the question that I was going to have, you kind of already started now getting into, but maybe with that context, you can develop on your answer even further. The question is, how should those constraints guide the design of the AI systems that we now build?
I think one thing is it's not necessarily the case that they have to. So I would think about those constraints as a good way of characterizing what the difference is between human minds and our AI systems, right? So human minds solve a set of computational problems that are characterized by these constraints. We live only, a few decades, give or take. We have to do all the things we're going to do using just a couple pounds of, neurons, right? And we can only communicate with one another by, making weird honking noises or wiggling our fingers on a keyboard, right? Like those are the kinds of constraints that humans operate under, right? And so as a consequence, we have to be able to learn from small amounts of data because we're just not going to live long enough to see lots of data, right? It's not like AlphaZero, or AlphaGo, which is trained on many human lifetimes of Go games, right? You can't do that. Human Go players are going to be limited by what is possible to learn in a human lifetime. You have to be able to recognize the structure in problems so you can use previous solutions that you found or come up with good sort of efficient strategies for solving those problems using the limited computational resources you have, right? So like unlike Deep Blue, a human chess player can't search 100,000 positions per second. They can search much less than that, and they have to focus on finding the good ones to search. You can't overcome those constraints by, being able to transfer the data that we've experienced or pool our computational resources directly because we have to operate under those bandwidth limits. And so we have to come up with good conventions for allowing us to do things like work together and to pool data, things like writing, language in the first place, but writing, science, starting companies, right? These are all mechanisms that we can have for being able to coordinate the resources that are available to us. And so that set of things really characterizes, in some sense, what it is to be a human as an intelligent system. And our AI systems are not subject to any of those constraints, right? They can learn from many human lifetimes. They can add more compute when more compute is needed. They can transfer state or share the data that they train from. All of those things are much more straightforward for your AI systems. So one consequence of that is that you might expect that the AI systems are just going to be a different kind of intelligence from human intelligence, right? Because they're not operating under the same constraints, they're not solving the same computational problems. They're going to be able to solve problems potentially really well. And in some cases, they're going to solve those problems better than humans, but they're not necessarily going to solve them in ways that are recognizable to humans or ways that are the same as the solutions that humans find. And so that sets up sort of two possibilities. One possibility is we say, that's fine. We just want to engineer the best systems we can. We should just keep on doing what we're doing, keep going in that direction. And we're going to get this kind of divergence between what human intelligence is like and what AI is like. And that's okay. The other approach you could think about is one of saying, oh, well, actually, we want some of those attributes of human intelligence to be inside our AI systems. In particular, it might help us make AI systems that just make more sense to us, right, in the kinds of solutions that they find. And so if we want to do that, then we really need to understand the things that are going on the human side and think about how it is that we transfer those over. And so we talked about meta-learning as a trick for building systems that have inductive biases that are maybe more like humans. That's certainly an avenue that you can go down if you want to do that. But engineering inductive bias is hard. Scaling is much easier than engineering inductive bias. And that's the reason why we're in the current sort of moment that we're in AI, is that that's a technique that sort of works and it's an engineering problem. We know how to solve it. But engineering inductive bias really requires having an understanding of the problems that we're solving and what reasonable inductive biases for those problems are. And it's something that people are still trying to figure out how to do well.